Hello my friends, in this video we will be going over 1996 AIME problem number 10. Here's a view of this problem. We would like to find the smallest positive integer solution to this following expression. So solve it for x basically. So what I will do is I will make use of the claim that I produced in my produced and proved in my previous lecture. So the claim was that sine x plus cosine x is simply equal to root 2 times cosine of 45 minus x degrees, and we made the proof based on I replaced the root 2 here by 2 times cosine of 45 degrees, and then I used the product to sum formulas to establish this claim. So this is useful for me. What I will do now is to replace the right hand side. So let's start with tangent of 19 x degrees is equal to, so I will replace the numerator and the denominator by the expression following here. So root 2 times cosine of 45 minus well, because the plus sign, I will have minus 96 degrees. And then here the problem is I have it with a minus sign here, so I should probably change these. So let me go ahead and replace the denominator here in the following fashion. So cosine of 96 is simply equal to minus cosine of, I believe, 84, and minus, so instead of sine of 96 I can just replace it with sine of 84 degrees as well. But notice that this thing here would be simply equal to minus cosine of 84 plus sine of 84 degrees, and now I can apply my claim. So minus root 2 times cosine of 45 degrees minus 84 degrees, and well, that thing is just minus root 2 times cosine of 39 degrees, but I can go ahead and replace cosine of 39 with 180 minus 39, which will come with a new negative sign. So therefore I would have root 2 times cosine of 141 degrees. So I would get, in the denominator, I would get root 2 times cosine of 141 degrees. But now the root 2's will cancel out, and this thing will be equal to, so that the numerator is simply now equal to cosine of minus 51 degrees, but that's the same thing as cosine of 51 degrees. And for the denominator I would have let's just keep the cosine of 141 degrees. Okay, now back to the numerator. Cosine of 51 is the same thing as sine of 39 degrees, and that one is equal to well, sine of 39 is the same thing as sine of 141 degrees, all divided by cosine of 141 degrees, and that does the trick that I was looking for, right? So therefore I got tangent of 141 degrees. Therefore this would imply that 19x would simply be equal to 141 in mod 180, or I should probably say 180 say y, and the rest of the now the problem has become a number theory problem. You can probably organize the right hand side such that it will have a multiple of 19. So I observe that it's possible to split this 141 so that you will get a multiple of 19 in the following way, I guess. So 19 times 7 plus, and the same thing with a multiple of 19, so 9y. So 7 times 19 would be 133. We are 8 short, so we need to add an 8 here, and then 9 times 19 is 171. We are 9 short, and so therefore we have 9y. So, but the left hand side is a multiple of 19. For the right hand side to be a multiple of 19, the second term must be a multiple of 19. So let's write that down. So this would imply that 8 plus 9y is equal to 19z. Now recall that so I came up with a new parameter here. Now from this we observe that the smallest x would be corresponding to the smallest y, and the smallest y would be corresponding with the smallest z. Now if I solve this expression for y, I get that y is simply equal to 2z plus z minus 8 over 9. And again, as we said, so we want the smallest y. So for the smallest y to happen, I can set z equal to 8, I guess, right? So if z is equal to 8, so I need to solve it for positive integers, obviously. So this fraction just vanishes. So all I get is that 2 times 8. So y becomes 16. And finally, going back to the original result here, let me change my color. Therefore, 19x would simply be equal to, let's see, 141 plus 180 degree times, 16. And when you solve this whole thing for x, it turns out x comes out very nicely as 159 degrees. So that's the solution, and we're done.